All right, this is Mr. F coming to you live from outside the school where we are going to take our acceleration cart data. Join us in just a second when we return. So what we have here is our cart. It is set up at the 0 centimeter mark. We are going to turn this fan cart on. It is going to go all the way down the pathway. As it goes down the pathway, we will be marking the time every 3 seconds. And now it's raining pine cones, or pine needles. So we'll be marking this every 3 seconds. So what we're going to do here is we're going to start our timer, and every 3 seconds we're going to make a mark on the concrete. You can see where some of our marks, our first trials, did not do so well. So we're going to start this fan up. Wow, you can see that fan. It is already to be taken off. Look at that thing go. Look at it blowing all the pine needles around. This is crazy. Look at it go. So we're going to get this fan cart ready. We're going to start our stopwatch. We're going to have our assistants get ready to mark every 3 seconds. And in 3, 2, 1. Mark.
Hi everyone. So what I failed to mention in the video is that our interval times will be 3 seconds up until 18 seconds, meaning that we'll be making a mark on the walkway at every 3 seconds. 3 seconds, 6 seconds, 9 seconds, 12, 15, and 18 seconds.
So again, this is Mr. F coming to you live from outside of the school where we are doing our acceleration fan cart lab. We've just did our trial. We had a line for every 3 seconds showing that we are increasing in distance, in interval distance, over each interval time of 3 seconds. So now what we're going to do is we're going to measure those out. To do that, we're going to take our handy dandy meter sticks. We're going to put them at the initial starting point. And then we are going to move down and continue to measure from the starting point. So for our first measurement, we see that we are 1 complete meter stick, which is 100 centimeters. And the mark falls at 75. There's our angle. So this would be 175 centimeters from the starting point. We're going to continue to do that for all of our marks. And as we've done that, we see our next mark is at 460.5 centimeters. Our third mark, 846 centimeters. Our fourth mark, 1,270.5 centimeters. Our next mark, 1,694 centimeters. And our last mark at 18 seconds goes to 2,124 centimeters. Now please make sure and understand those values that you've just seen, those go in the second column of your data table. The second column of the data table being the distance from the starting point. So looking at our data table, we can fill in the time interval every 3 seconds, 0, 3, 6, 9, 12, 15, and 18 seconds. And then for our distance from the starting point, we started at 0. Then our next measurement was at 175. Sorry, I made a little mistake there, guys. 175. Remember, these are all centimeters. Then 460.5, 846, 1,270.5, 1,694, and finally 2,124. From here, we can then go on to calculate our displacement interval. That is looking at this and its previous. So we moved 175 centimeters. This displacement would be looking at this to its previous. So we would subtract the 2. And that would give us 285.5. You could do the remainder. With regard to the instantaneous velocity, we are doing the displacement covered by the time intervals. So that would be 175 by 3. And that would give us 58.3. And then for the instantaneous acceleration, we're looking at the change in velocity, which was 58.3 from 0, and we divide that again by the time interval, and that would give us 19.4. So again, please understand where we're getting these values from. 19.4 centimeters per second squared. Please understand where we're getting these values from. We're going through and we're always dividing by an interval of 3. From there, we can get the displacement interval by subtracting the one from the previous one. We can calculate velocity, and we can go through and calculate instantaneous acceleration. All right, everybody. Start working on your data tables. I'll see you in just a second. All right, everybody. I hope this has helped you to better understand the lab, to get an idea for what we've covered with regard to the fan cart acceleration lab. The most important things to take from this are that we are increasing those interval distances with every time interval of 3 seconds, which tells us that the cart is accelerating. Okay, it does not have a constant velocity. If it had a constant velocity, it would have been like the previous lab, and those interval distances, those displacements, would have been the same each and every time, but they're not. They continually get larger and larger and larger. So make sure you go through, answer those questions, make the graphs. Okay, don't forget your trend lines, your slope, and that is pretty much it. So I hope you guys have enjoyed this video, and if I can be of any help or answer any questions, please feel free to email me or go through the Teams app on your computer. And until that, we will close the door on physics for today and open it yet another day. So hope you've enjoyed Fabianski's Fun Physics Classroom, and I will see you guys in the next episode. Take care, everybody. Bye-bye.